Good morning, everyone. I'm Lucas. Today, I'm going to explain the implement of MLP for nonlinear separable data. In this MLP, to solve the classified problems using a XOR function experiment and help us to explore how the neural networks solve the nonlinear problems and why the MLP unique layer structure in such a powerful tools in AI. Okay, we are see our observation in our experiment. Okay, in this observation, in this graph, we have two goal. In our main goal of this MLP to clarify the input based on the XOR function. Now, for a quick refresh, XOR gate is a logic operator that output is true and only when the input is differ. Okay, straightforward. But here, where it's get interesting, XOR cannot be solved by the simple linear classification. Why it's famous for challenging based AI model? They observe of this experiment to show how the MLP with their hidden layer can address this challenge by capturing complex pattern in data. Okay, next I will explain the coding. Okay, first I will import the libraries n numpy, pandas, IO and matplotlib.pyplot. In this library, NumPy is used for storing of numerical operators, including array, matrix, etc. But pandas and IO is not directly used in this code. We use for data manipulating, and matplotlib is used to plot the graph for the given data set. X is an input data and Y is an output data and NX is an input neuron and NY is an output neuron and NH is an hidden neuron. By this given neuron, we have to learn we are using the weight update steps. We are use this weight update steps in this M is equal to X dot shape. Next, IR is equal to 0.1, which means that to learn the weight of the updating steps. And random seeds is random seeds to reproduce the random values or random seeds. Next, apply the sigma activities. Next, we apply the sigma activities. The sigma is help to validate or convert the range between 0 and 1. Next, Z1 and Z2, A1 and A2. Z1 and A1 is an hidden layer and Z2 and A2 is an output layer. By using a back propagation, we use a TZ2 and a DW2 is an output layer and DZ1 and DW1 is an hidden layer. By next we train the data. Next we train the data loop running iteration of 10,000 in this case. Next we run the loop and get loss comparatively binary cross interlosses. Next, we need to weight update using the grading calculator base pair. Okay, next we predict the data and test the data. After we get the output is 1 and 0 and 1 0 1 0. Okay, finally we see our result of the given graph. Okay, next we see the result of the given graph. Once we train the data in the computer, we test the model on the different XOR gate input. Okay, in this gate we have to get 1 0 1 1 0 1 0 0 is an input. We get 1 0 1 0 is an output. In this, in the training classification, input or get correctly, and MLP now trained classify their inputs and achieve the 1 is an input that differ and 0 is a same. So to visualize, we can see the loss over the here. To loss the data and continuously lost. Thank you.